So this looks familiar, this notation here, right? Looks like the ratio test. So what we can do with series when we have a variable instead of just having plain old numbers is that we can still apply the ratio or the root test. Just remember that the ratio needs to be less than 1 for it to converge. Right? So if we apply the ratio test here in symbols, that's the limit as n goes to infinity of a sub n plus 1 times x to the n plus 1 power over 8 to the n plus 1 divided by a to the n x to the nth over 8 to the nth power. So we can flip and multiply the second fraction. So this is going to be a to the n plus 1 over a to the nth times, sorry, I'm probably doing too many steps at once here. Let's just keep this fraction. And we're going to flip and multiply the second fraction. Because if we do that, then we can write the a to the n plus 1 over a to the nth term off to the side, and that's where that limit's going to come in handy that we were given at the beginning, that this limit was going to be 1. And then here we have x to the n plus 1 divided by x to the nth, so that's just x to the first. And 8 to the nth over a to the nth plus 1, that leaves 8 to the first on bottom. Okay, so we know that this limit is going to go towards 1. So x over 8 is what's really going to determine our ratio, the a to the n plus 1 over n, over a to the n. This needs to be less than 1, right? By the ratio test, if you divide the next term by the current term, that needs to be less than 1 for us to be for us to have a convergent series. And actually, I should note this is the absolute value, right? When you apply the ratio test, the way our book has made the notation is that's the absolute value. So we just need to solve this inequality, which means we got to solve it twice. Once if it was positive, and then once if it was negative. Because if we're greater than -1 but less than 1, then the absolute value would make us be less than 1. So we're just solving this inequality here. And if we do that, we get x is less than 8 and x is greater than -8. So -8, between -8 and +8 for x, this series should converge. So that means the radius of convergence is 8, because that's the distance from, that's like a distance from one endpoint of the interval to the center, like a radius of a circle, you know. The distance from one endpoint of the outside of the circle to the center.